Hello, my name is Jung Lee, and I am a senior at TUK. Today, we are talking about LiDAR technology. With the rise of autonomous driving technology, sensors like LiDAR and depth cameras have become essential areas of study. These sensors are critical for enabling vehicles to perceive their environment, detect obstacles, and navigate effectively. So, this reason I choose LiDAR technology in this seminar. LiDAR sensor is the advantage of lasers, which can generate pulse signals with high energy density and short wavelength for precise measurements of object in the distance. So yeah, in this seminar, I will introduce technology for using LiDAR with ROS. Before we begin, I'd like to remind you that this seminar focuses on the concepts of LiDAR technologies, not the practical implementation. So with that in mind, let's get started. Yeah, first, ROS is the robotic software platform includes functions such as a low-level device control, sensing and perception, localization, and navigation. And it has the inter-process communication through topics, service, and the action. Yeah, in this terminal screenshot, we can see a list at active ROS topic using the command ROS topic list. So yeah, this topic represents that streams in the ROS environment that allows nodes to communicate with each others like this. And in this list, we can see a scan topic. Yeah, this topic is particularly important because it indicated that the LiDAR sensors is actively publishing the data. Yeah, to examine the data being published on this topic, we can use the following command called ROS topic echo. Yeah, this command displays the real-time data being output by the LiDAR sensors to the information includes key parameters. You can see the frame ID, the range of angles scanned, and the distance measurements. Distance measurements. By inspecting this data, we can verify that the LiDAR is functioning correctly and providing accurate scan results. This diagram is really important. This is the communication architectures of the ROS environment, focusing on the relationship between nodes and topics. Yeah, this circle represents nodes and this rectangle represents topics. Here we can see that the Y node published the scan topic and the red color nodes represents the temporary nodes I created earlier using the ROS topic echo command twice. Since those nodes were stopped after the echo commands were terminated, they are now shown in red. Yeah, this diagram was generated using the ArcticGraph, which provides a clear overview of the current state of the nodes and topic in the ROS system. It's a very useful tool, so please keep in mind. To effectively utilize this sensor, a useful tool is RBG. This main capability of RBG is to visualize sensor data, allowing you to see obstacles or structure around the robot. And this is I visualize the laser scan data using RBG. Yeah, and this is the RQT graph. When you check the RQT graph again, you can see the LiDAR is actively uh, LiDAR is actively publishing data scan and it being subscribed to RBG. So I have visualized the LiDAR data using RBG. This visualization allows us to explore and attempt various advanced techniques such as mapping to creating a map of the robot's surrounding environment or SLAM to estimate the robot position and navigation to a target location while avoiding obstacles. So the technique I will introduce today is the Hector Slam. Yeah, this Hector Slam is the type of indoor slam technology that does not require autometry and operates solely based on the LiDAR data. To explain the key feature of Hector Slam, this image is essential. It represents the TF3 in rows showing the relationship between different coordinate frames. These frames provide the positional information necessary to track the robot's current location. First, map frame is represents the goal, a global coordinate system providing a reference of the robot's position based on the map generated by SLAM. In Hector SLAM, the map is built around this frame. Next, outer frame is intermediate frame between the map and base footprint frames, typically used to represent the robot's position during movement, while using the reliant of wheel encoders or short-term position change. But Hector SLAM does not require in these encoders. And laser and last, base, you can see the base footprint frame defines the frame at the robot base special line, the point where the wheels contact the ground. It serves as a critical reference for determining the robot's position and planning its movement path. Next, the base link frame represents the center of the robot's body, typically located at the robot's center point. Various sensors and components are positioned relative to this frame. And the base stabilized frame is the stabilized version of the base link frame. It usually utilizes sensors such as the IMU. Last, the laser's link frame is represents the position of the LiDAR sensor. LiDAR scan data is collected based on this frame, and it's used by SLAM algorithms to perceive the surrounding environment. In HydroSLAM, the laser link frame is used to collect LiDAR data, which is used to generate maps and estimate real-time positions. So it relies on TF as map to base link and base link to laser link to generate maps and estimate real-time position. Here are some other SLAM technology. There's a G mapping is a particularly filtered based 2D SLAM algorithm. It utilized LiDAR and autometry data to simultaneously estimate the robot position and map. And the SLAM toolbox is a modern 2D SLAM library mainly used in ROS 2. It provides various SLAM functions and it's particularly powerful in initial robot pose estimation and map updating. And then last is the cut wrapper is a SLAM algorithm developed by Google that supports 2D and 3D SLAM both. It generates high precision maps using LiDAR and IMU data. Now, next is the navigation part. Navigation is a system that determines how to reach the specified target location and autonomously moves to that point. Algorithm related to navigation is ASHAP and Digested, among others. So let's talk about move base in the context of navigation. Move base is a package in ROS that brings together various components related to navigation. It is widely used when you use navigation function. The first step is setting up the navigation style. This involves loading the map created through mapping with map server. Sensor source provides real-time sensor data to detect the robot's current state and its surrounding environment. Two main data is layer scan and point cloud. Second, this part is represents some of the components of ROS navigation stack. AMCL is estimate the robot's positions within a 2D stack map by comparing sensor data. And sensor transforms is handle coordinate transformations between different sensors within the robot system, ensuring all sensor data is aligned and meaningful in the same reference frame. And the automatic source is the tracks the robot self motion state, primarily using data from field encoders and the IMU, providing information about velocity and position changes. Yeah. So yeah, last this part is the cost map and planner part. There are global part and local part in this page. Global part it have global cost map and global planner. The global cost map loaded from the map server integrate multiple layers, including the obstacle layer and the inflation layer. The planner utilizing the global cost map is responsible for generating the global path, ensuring smooth and efficient navigation. Next is local part. There are local cost map and the local planner. Local cost map is a map generated based on sensor data around the robot. It represents the immediate environment of the robot. And the local planner is works with both the global path and the local cost map. Yeah, responsible for creating the local path and determining the robot velocity to move along the path. If the robot encounters obstacles or issues during the navigation, it executes recovery behaviors. In such case, actions like moving backward or rotating. Based on all this information, the navigation operates, enabling the robot to move effectively. So yeah, thank you for attention to my seminar. And do you have any questions? Okay, second.